Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from 0 to infinity, e to the x divided by e to the 2x plus 3 dx. This is an improper integral, so we have to use the definition. So this is the limit as b goes to infinity. Integral from 0 to b, e to the x over e to the 2x plus 3 dx. In order to evaluate this, we're going to have to find an antiderivative of e to the x over e to the 2x. Well, notice that e to the 2x is the same as e to the x squared and also 3 is the same as the square root of 3 squared. So we do a small substitution. Let u be equal to e to the x, then du is equal to e to the x dx. So this integral becomes the integral 1 over u squared plus the square root of 3 squared dx. This integral is equal to 1 over the square root of 3 arctangent of u over the square root of 3. And u is equal to e to the x. So we have 1 over the square root of 3 arctangent e to the x divided by the square root of 3. That's our antiderivative. So this now becomes the limit as b goes to infinity, 1 over the square root of 3 arctangent e to the x divided by the square root of 3, evaluated from 0 to b. So first we substitute in b. So e to the b divided by the square root of 3 minus, then we substitute in 0 the term on the right, should be a square root of 3, is a constant. So when you take its limit, you just end up with that constant. Notice that e to the 0 is equal to 1. So this second term becomes 1 over the square root of 3 arctangent of 1 over the square root of 3. And we may evaluate that some more shortly. For our first term, we need to be able to evaluate the limit of the arctangent of e to the b over the square root of 3. We need to know something about the arctangent function. Remember that the arctangent function has a graph which has horizontal asymptotes at pi over 2 and negative pi over 2. And the graph itself looks like this. So as the input of the arctangent, that is the x-coordinate, gets bigger and bigger, the output, which is the y-coordinate, gets closer to the pi over 2. And that's what we have. That's the situation we have. B is getting closer to infinity, so e to the b is getting closer to infinity. When you divide that by the square root of 3, you're still getting closer to infinity. So you're taking the arctangent of something that's getting larger and larger and larger. And as we already said in the graph, this part of the graph tells us that that arctangent then approaches pi over 2. So this limit becomes 1 over the square root of 3 times pi over 2 minus the 1 over the square root of 3 arctangent of 1 over the square root of 3. Arctangent of 1 over the square root of 3, if you remember back to your unit circle, this is a unit circle centered at the origin with radius 1. The arctangent of 1 over the square root of 3 is going to be the angle where the tangent is equal to 1 over the square root of 3. Tangent is sine over cosine, so we need the cosine to be the square root of 3 over 2, the sine to be 1/2, and that will give us a tangent of 1 over the square root of 3. So this happens exactly at pi over 6. And so we have pi divided by 2 square root of 3 minus pi divided by 6 square roots of 3. This tells us that our integral that we started with, the integral from 0 to infinity e to the x divided by e to the 2x plus 3 dx, converges and is equal to this value that we found. So the integral from 0 to infinity e to the x divided by e to the 2x plus 3 converges and is equal to pi divided by 2 square roots of 3 minus pi divided by 6 square roots of 3.